Alright, we're going to take a little bit of time here to work on dimensional analysis. This can also be called unit analysis, so if you hear either one throughout the class, just make sure you understand it's the same thing. The book does it slightly different. We focus more on the units, they focus more on the dimension. So where we would put x is going to be in meters, they would instead put length. It works the exact same way, but just so that when you see it in the book as either length or time or volume, any of these dimensions can also be done with unit analysis. It's the exact same thing. Alright, so what we're going to do is we're going to take an equation right here. Okay. For right now, we're just going to highlight, is this equation correct or not? What we know is that both sides of the equation have to have the exact same dimensions or the same units. And we're going to, again, focus more on the units part. So, x has the units, and we'll use this throughout today. X has the units of meters. V will have, or velocity will have the units of meters per second. A will have the units of meters per second squared, and T has the units of seconds. So wherever you see these in the equation, you'll replace them with their appropriate units just to check to see whether or not the units are the same on both sides. So x here, you can put this in brackets to make it a little bit neater, but I'm not going to. So x is going to be meters. 1/2 does not have any units at all. And since we're only looking at the units to see whether or not the equation is viable, we can completely ignore this right now. In other words, if you were to have an equation of 1/2 distance units are going to be in meters, 1/2 of that is still going to be in meters, and so the 1/2 has no effect, and therefore we will ignore it for this purpose. Velocity, as you can see over here, is going to be in meters per second, and t is going to be in seconds. Be careful when putting fractions. I really strongly suggest using the horizontal bar in order to you find it easier to know when to cancel things. This is of course s over 1, and so this will in fact cancel. You'll notice that meters is the same on both sides, and so yes, this is dimensionally correct. What this does is if we have an equation and we're not quite sure about it, especially in a lab situation, we can check the dimensions to see, this is just a simple thing to begin with, to see whether or not it's correct. It's not foolproof because you'll notice, as we pointed out a moment ago, the 1/2 or any constants in there are not addressed by this, and so if this 1/2 is incorrect, it will still be dimensionally correct, but it will not be a correct equation. So, but the purpose for right now, yes. Now let's look at a slightly more complicated one down here. Okay. Again, notice we have a constant here. That's going to be ignored. Powers are not going to be ignored. So the 1/2 right here. Notice that when something is taking square root or to the 1/2, that everything in here will go to the 1/2 power. Well, what I'm going to do is I'm actually going to take care of everything in here to begin with, and then square root it on the very end. So velocity is going to be in meters per second. Again, next to a t, which is in seconds, all over meters per second squared. I don't know why this is slightly angled. I'm not sure what's going on there. Oh well. Anyway, and the whole thing is square root. Okay, I'm going to give myself some space to do some work over here in just a minute. But then I'll come over here and do the other side. 1/2, again we ignore. The m for x, and velocity is going to be in meters per second. When we have complex fractions, the way to solve that is to multiply by the reciprocal of the denominator, which cancels the denominator and puts that same thing on top. The s's will cancel here from before. You'll notice that the meters actually cancel here, leaving me with, I'm going to simplify all this right down here, s squared square root, which will eventually be, I'm getting more angled and I don't know why. It's a little bit frustrating. I'm going to fix this in future videos, hopefully. Alright, and simplify this side. We have meters over meters per second. Again, multiply by the reciprocal. M's cancel. That cancels, leaving me with S. This is kind of complicated here, so let's break this down. If you need to pause to try to analyze what the heck I just did, feel free. Anyway, both of these are dimensionally correct. Alright, let's look what would happen if we had another term over here on the side, like, let's just go with it, very basic real quick, a over t squared. Let's go squared on that. Okay. Now we know the answer to this already. This part right here is going to be s, so I'm not going to redo it. This right here is going to be s, and so let's just see this one right over here. This is going to be m over s squared divided by s squared. Now what I wanted to show you here is that if you look at this, you might inherently go, hey, these cancel, if you're not careful, because this is actually s squared over 1. If I multiply by the reciprocal and I'm careful with things, what I'll notice is this does not cancel at all. As a matter of fact, this right here, there shouldn't be a plus there. Let's get rid of that real quick. Go away. Okay. That this is in fact going to be m over s to the 4th. So if this term were in here, this would not be dimensionally correct.